time I clap my hands, someone, somewhere, is wrong on the internet. Now, being wrong in general, that's not actually a noteworthy thing, but wrong on the internet is a really special kind of wrong. It's Donald Trump presidential campaign wrong. It's the kind of wrong where if I say today is Tuesday and someone says actually today is Monday, I turn to them and say, I'm going to come into your house and I'm going to set fire to your bed. And you can see this wonderful level of discord in any YouTube comments thread that you care to peruse, but the true connoisseurs of internet drama know that you need to find the niche forums to get the best internet drama. I frequent, for example, a knitting forum, and knitters are lovely. I mean, we sit around and we chat and we knit hats for babies. And then they find out that you knit a hat for a baby out of the wrong yarn. You are Hitler. And usually I do the only sensible thing when it comes to internet drama, and I take out the popcorn and I enjoy the spectacle. But sometimes I feel kind of professionally obliged to maybe kind of jump in there and correct a few things. So I'm not like an astro person, I'm actually a quantum physicist. And it may surprise some of you to learn that occasionally people are wrong about quantum physics on the internet. And one thing that comes up quite frequently is the idea of quantum teleportation. And being a quantum physicist discussing quantum teleportation online is like crushing people's dreams, just one by one. So let's have a think about it, like what is quantum teleportation? Now, like I'm a physicist, so I like to start things small. So I have an atom here, and I want to teleport it to Peake over there at the back. And the atom's here, and it disappears, and it appears in Peake's hand. And that's what we think about when we think about teleportation. That's not actually what quantum teleportation is. So what actually happened is that I had a chat with Peake before we started off, and I had a pair of entangled particles, and I gave Peake one of these particles, and I have one here, and now I have the atom that I actually want to teleport. So I now do some science, and what actually happens now is that the information on my atom basically kind of travels through the entanglement and appears on the entangled particle at the back. Now, if you've been paying attention, you might have noticed at the start here we had an entangled particle, an atom, and at the end we have an entangled particle. Nothing has moved. So this is kind of like the exact opposite of what people tend to think of when they think of teleportation. But what's actually moved is the information. It's the information that was on this atom, the quantum information, that has moved and is now at the back of the room. So it's a bit disappointing. Crushing those little dreams. But people they're quite resilient. And they're like, Suzanne, it's okay, we can fix this. This can still be cool. Faster than light communication. Like, the information disappears from here, and it appears over there, and it's like instantaneous, right? I kind of skipped a step. So what actually happens is that, and I do the science, like before, but then I have to take out my phone, which is a very slower than my communication process, and I call up and say, yeah, I did the science thing, and now you have to push the other button. Who wants to set fire to my bed? And I mean, I'm being a bit of, Dr. Downer here. I mean, nobody wants teleportation more than me, because I commute from Edinburgh to Glasgow every day. But I know, I'm complaining here, but I know compared to like a climatologist or an immunologist, I kind of have it easy when it comes to people being wrong on the internet. Because people like quantum physics, they tend to be pro-quantum physics, they're really enthusiastic, they're just wrong. Like, constantly. And I can understand, because quantum physics is kind of a little bit weird. It is, like, pretty much by definition, very different from the everyday life that we interact with here. And it can be hard if you don't have the background in quantum physics to look at someone online and know whether or not they are, someone who knows what they're talking about, like the Canadian Prime Minister, or someone who's just, waffling away. So I thought what I'd do with the brief amount of time I have in front of you now is to explain a little bit about my own research, so you'll be able to kind of recognise what real quantum physics research sounds like. So, like I said, I like to start small, so I'm going to start small with you. I want you all to think of a number. I want you to add 1 and take 1 away. Is that your number? Follow-up question, did anyone else think X? It's a very simple, straightforward idea. You add something, but then you immediately take it away. It's kind of mathematically equivalent to it never having been there in the first place. And you can take these kind of concepts you know from numbers and kind of bring them to more abstract concepts, like I am one person on this stage in front of you. And I'm going to say that's mathematically equivalent to one person, me, plus Tom Hiddleston, minus Tom Hiddleston. That's mathematically equivalent to what you see here. Now, I know he's not really here. I just have really aspirational mathematics. So that's our first concept. And the second concept is another quite simple one. I am one whole human, which I am two half humans. Okay? So now I'm going to combine those two concepts. I'm going to say, in front of you on the stage here, we have one half a human, another half a human, plus half a horse, minus half a horse. Right? It's perfectly, just exactly what you can see in front of you. I'm going to just rearrange that ever so slightly. So we've got half a human, and half a horse, and half a human, and minus half a horse. Centaur. Now, obviously, this can be generalized to mermaids, fauns, and a variety of mythical creatures. Now, why would we actually bother going through all this rigmarole? Well, horses and humans are actually very easy to interact with, but sometimes you need the quantum properties of a centaur to kind of do some new and interesting things, like quantum teleportation. So the thing is, you can't see the centaur. If you can see the centaur, please get a taxi home this evening. So why can't you see the centaur? Well, the problem is I've still got half a human and minus half a horse sitting on the stage, and that's why you can't see the centaur. So if I want to be able to access these quantum properties of the centaur, what I need to do is figure out how to get rid of half a human and minus half a horse. So now that I've explained a bit about my research, you can go home, and in the future you'll be able to tell real quantum physics, like the stuff I do, from complete and utter nonsense. So thank you very much. I hope you've enjoyed yourselves and learned something. And just remember, every time you clap, someone is wrong on the internet.